And we can just say a set is a well-defined collection of objects. If you can tell me whether or not something is in the set, you have a set. These objects can be numbers or they might not be numbers. And in this class, they'll mostly be numbers. But if you take other math classes, you'll definitely see situations where you're thinking about sets that aren't numbers. In calculus, we work with a special type of set called an interval. These intervals are defined by their endpoints. And the two types of intervals that we're going to talk about are closed intervals and open intervals. It's a square bracket with two numbers between it. It looks like a point, but you have square brackets instead of round brackets. What that will look like is, for instance, if I have the closed interval -10 to -5, it will look like this. It will be all of the numbers that you could possibly have between -10 and -5, and also including the endpoints -10 and -5. Now I can't list all these numbers because there are infinitely many. It's also important to know that you know this symbol, which looks like an E that's partially erased. I think this is C for contained in, because what it means is when I look at this interval, this number is in it, is part of it. So here's some true statements we could make about our interval -10, -5, our closed interval -10, -5. It would be correct to say that -7 is in this interval. And it would be correct to say that -10 is in this interval because the square bracket means that this is included. It would not be true to say that 0 is in this interval because 0 is not between -10 and -5, and it also would not be true to say that pi is in it. And the key here is we're trying to introduce this in notation so that you understand what this means by pointing out places where it works and where it doesn't work. Any questions, thoughts, or controversies on anything I have said so far? Okay, then there's also the notion of an open interval. Open intervals include all of the numbers between their endpoints, but they don't include their endpoints. So this is where you're going to see open circles to indicate something is not included. For instance, the interval 3, 7, the open interval 3, 7 contains all numbers between 3 and 7, but it does not contain 3 or 7. So this is the situation that you may have seen before, where you would have, so I'll put open circles at 3, 0. I click hold to bring up this menu where I can make an open circle, and I'd like to make it bigger. And then I could do 7, 0. And the key here is that 3 and the 7 are not included. So these are closed intervals and open intervals.